everybody. Hi. We have just a few new faces in the crowd, so welcome and thank you for coming. I'd like to first have a big thank you for a new venue, M&A. Even the locals are like, where's M&A? So this used to be Topo Gigio's, but Mikey Nicholson, our new host and his team, thank you very much. And we're excited because, of course, we'd like to bring See and Learn to the bottom, not just windward side. So we were happy when they approached us to do this. I also want to do a little shout out to a couple volunteers that we have. So Shelly and Jeff, if you could raise your hands. So they're making, Shelly and Jeff Jolie own a home here and offered to help us this year, and it's really wonderful. They're doing a lot of the school activities for us, which gives Emily and me time to do all the other things that we need to do for the event and the foundation as things are going on. And Larry and Sherry, they not only own a house here and donate to our raffle, but she's checking who's in the taxi or not. So, thank. Yeah. No, leave no participant behind. We also have other sponsors in the crowd. Tim, who has the wonderful home in St. Croix. You can win that in the raffle. Michael is still in charge of Iris House. And Dries is here, who's a board member and also owns El Mamo Cottages. Did I miss anybody? Anyway. Oh, and Michael's also a board member. Sorry. He's the one who has to sign things. And a hello to anyone watching online. Thank you for supporting us in that way. And if you're not on Saba this week, boy, you should be. It is unbelievably flat, calm, incredible diving weather, and it's a little hot, but not in your air-conditioned hotel room at night, so you should be here. Anyway, so let's get started. We also have our scientists who have been doing activities the last couple days. So Dr. Eric Schneider is here. Orion is here. They're leaving soon. They've done great stuff. So check out our social media to see the work that they've done. And we're going to talk about what's coming up because we have in the crowd Dr. Allison Robertson, who arrived this morning. And we're going to talk about what she's going to be doing the next few days. And another reason to get out on a boat, it's flat calm. We're going to go out to the Saba Bank with her. So, okay, so let's really get going. So our program is made possible by lots of people, lots of sponsors on the island. But our big supporters are public entity Saba, another way of saying the government. CCG is the rebranded. We used to tell you it was Prince Bernhard Culture Funds. If we went back, sorry, Carib Trans supports our live streaming, and so does Satel is our local communications company, and they make a big effort to make our live streaming possible. These are the more than, I think we're 60 sponsors. Thought you fixed that, Emily. Okay. There I was blaming Emily. So if you can do a thank you to the many sponsors when you're walking around town. Emily is here in the audience, the other Emily. So she is Everything's and the wonderful 5 Square Gallery. But as you can see, almost every business on the island supports this program. Hassle Free supports bringing in our cargo and different things. That's why. Sorry, I'm like looking, wait a minute. They are also a new sponsor. Thank you, Vernon and family. So Hassle Free, we didn't have a different logo for, but they are the supporters of the accommodations where tonight's speakers are staying at a nice apartment. And they are supporting the rest of our Critter Quest scientists. So another reason to come back to Saba, January through March, we kind of have a mini See and Learn going on all those 3 months based on critters. I think we told you about the raffle, but for our people online, by all means, have a look. Incredible prizes. If you buy $50 or more, we can set up a way that you can easily send the money to us electronically. Not easy for a $5 ticket, but please support us. So, what's coming up next? Tomorrow morning at 9 o'clock, we're sure that after tonight's presentation, you are going to want to sign up and be part of the hike to check out insects and learn more. But once you see tonight, you're going to be convinced. On Monday, we're at the Busy Bee at Breadline Plaza talking about what's on your plate. Is that seafood safe? Marine toxins, and that's with Dr. Ellison Robertson. So you can sign up at the tent. I'll be there all day tomorrow, Emily in and out. And if you do a field project with us, you get one of our cool shirts. And not only do they look good, you can feel good about them. They're made from recycled plastic bottles. They feel good. Sounds like sticky, but they're not. And let's get on for tonight's real presentation. So, we hope tonight's presentation won't bug you. Jan Wieringa is a scientist at the Naturalist Biodiversity Center. He has had a passion for insects since childhood and developed an interest in plants during his biology studies, culminating in a PhD on large African trees. He has spent several years collecting plants and insects in tropical Africa, particularly Gabon. In addition to his research, Jan has lectured and taught field courses at various universities, focusing on flora and fauna. His current research interests include, careful here, Emily, who took Latin, throws these in to make sure I make a fool of myself here. Orthoptera, Orthopoda, therefore this one is Cleopoda, and Hymenoptera. Close enough, which means crickets, beetles, and wasps. So joining Jan will be his colleague Aglaia Bouma. After a near-fatal accident with a hornet, and if you hear this whole story, it's pretty crazy, Aglaia developed an insect phobia that lasted over 20 years. Wouldn't you? To overcome her fears, she started studying insects and eventually became an entomologist with a mission to make humans appreciate or even love insects more. She is now a researcher of entomology at Naturalist Biodiversity Center, where she teaches a flora and fauna course at the University of Amsterdam and is the author of several popular scientific books on insects. Antennas up for Jan and Aglaia.
The major biodiversity hotspot in the Netherlands nowadays. A bit more than 10 years ago, all the major naturalistic collections that were scattered over the university were all concentrated into this one center. So it's not part of the university. It's located in Leiden, and we have now 40 million specimens of plants, mosses, fungi, insects, birds, dinosaurs, but also stones. But a quite large part of that. On that huge collection, which is now the 5th worldwide, there's a whole group of scientists doing science on that collection. But next to having a collection and scientists and being a research institute, we also have a public exposition, so a natural history museum. And within the Netherlands, we're mostly known for that because people go to the museum and don't know what's happening behind the screens, of course. But I have to warn you, if you go there, don't watch out for many insects. It's mostly birds, mammals, and dinosaurs. Horrible. Okay. This talk will be about insects. And, well, as you can see, there are
loads of different species of insects. And most people, when they think about insects, they think about the big stuff. So butterflies, large beetles, large grasshoppers. But actually, the majority of species is really, really tiny. Um, most insects are only 1 or 2 millimeters large, and you don't see them. So, if you want to study insects, you have to find ways of also finding the small stuff. And that's one of our topics tomorrow on our walk. We probably won't walk that far. If you're disabled, you can come. We won't get further than 50 meters probably. But um, so insects, there are 1 million species described nowadays, but estimates are that there might be 5 million species of insects, and or even far more. But the last good guess is 5 million, which means that the majority of species has never been described. We don't know them. And to get a bit an overview within those million species, entomologists classify these species into orders. If you don't know what an order is a major branch of the evolutionary tree. And to compare this to mammals, which we know better, primates are an order, bats are an order, whales are an order. And then if you compare that to insects, butterflies and moths are an order, and beetles are an order.
Okay, so insects are arthropods. They belong to a larger group. And arthropods can be recognized by having an external skeleton. We've got our firmness inside, right? Our bones. And arthropods have it outside. And that skeleton consists of segments. And you can imagine it like some kind of harness. There are plates connected to each other. And the body itself is segmented, but also are the legs and the antennae. And interesting about arthropods is that they cannot grow. You can imagine if you wear a harness and you want to grow, well, you can't because you're in a harness. So they have to burst out of their own old skin, as it were, and then underneath is a new skin, so they crawl out of their old skin. The new skin is still soft, so they can blow themselves up a little bit. And then the new skin hardens, and they have some space to grow. So that's, okay, arthropods. Scorpions, everybody knows them. Isopods, spiders, of course. And insects are arthropods as well. But how are insects or how do they belong to the arthropods? How do you recognize an insect within this group? Well, how it gets nice. Okay, an insect has 2 incisions in its body. Actually, that's what the word insect is from. It's from Latin meaning insectum, incision. And that makes 3 body parts. So it has a head, a thorax, and an abdomen. And on this head are amazing little things. They have eyes, but not eyes like ours. They have compound eyes. And these eyes consist of little tubes, as it were. They're called ommatidia, and light comes into them. And every ommatidium sees quite a tiny bit of the world, so they see a lot of little dots, a lot of pixels, as it were, but not very sharp. So you can imagine they see not too sharp photograph, but they can see them well, and they can see other colors than we do. They can see UV, but not red, mostly. They also have these 3 dots, in this case on top of their head, but sometimes on other places. All right, I'll go to this side. Ocelli, they are called. Simple eyes, and they can't really see with them, but they can see light and dark, and they can see the horizon. And that's very important. Imagine you're a small little bee, and you're flying around, and whoosh, Saban, wind hits you, and you're heading for the ground, but you can see the horizon, and you can just correct for it in an instant. That's what they are for. Then there are the antennae. They're also called feelers. And yes, they do feel with them, but they mostly smell with them and taste with them. So aren't insects amazing? They don't have a nose right here, no. They smell with their feelers. And of course, their mouth parts, they have chewing mouth parts. Those are the ones that yeah, were evolutionary oldest. But some others have lapping mouthparts like flies or bees, and some have sucking mouthparts like butterflies and bugs. I'll come to them later. Okay, then the thorax, this part. Those are muscles. That's what moves an insect, as it were. That consists actually of three plates, three segments, and the first segment, yeah, only has a pair of legs, and the other two segments have a pair of legs and usually a pair of wings. So insects have 6 legs in total. That's how you, yeah, recognize an insect instantly. And then the abdomen, yeah, not unimportant as well. It contains the genitalia. It contains the heart. So the heart is not like with us somewhere around here, but it's here and it pumps around blood. But the blood is not in a vessel system. It's pumped through the body. It's hanging loose in there. They do have a system like a vessel system, but that's where how oxygen is transported through the body. They have a network of oxygen tubes. And, well, the digestive system is there as well, of course. Now you can do this one.
Yeah, here we see another insect. This is a grasshopper. And again, we can see the 3 body parts. The head is really clear with the eyes, the compound eyes. Here the ocelli, the antenna is there, and here you can see its jaws and its tusters. It's
Palps.
palps. That's it. Yes. Then comes the thorax, which consists first of the pronotum, which only has this first leg pair, there's no wings, and the other 2 parts that do have wings and have legs. With this grasshopper, it's not really clear where the abdomen starts and where the thorax ends, if you don't know, but at the transition you also find the ear. At the very end of the abdomen, you see the ovipositor, which is a sexual organ, in this case for a female. An ovipositor are 4 valves that she uses to kind of dig in the ground or dig into some grasses and deposit eggs there. A bit above it, in this case quite small in this grasshopper, is a cercis, plural cerci, which is an appendix of the abdomen, and some insects have it, and either it's 2 or 3 cerci are possible, but not all insects you'll find this. Part of the segmented body, like Aglaia said, is the leg, and insect legs have a bit more parts than our legs, but we still try to use our own terms for it, which is of course anatomically completely incorrect, but never mind. First we start with the hip. We tend to have that. With us it's firmly attached to the rest of our body. With insects it's already the first part of the leg. Then a trochanter, which is really not visible with us. It's a kind of ring, usually, although in some species it's quite developed and large. But then a really large part, where with the grasshopper most of the muscles are in, is the femur or thigh. Then we got a shin, tibia, and we have a foot. And the foot consists of several parts, maximum 5, where the last segment usually has a pair of claws. So you have these 5 elements and then claws, which don't count as an element. In this case, the foot is really large. This is a honeybee, and honeybees collect pollen that they transport with their shins and foot, so they need it to be large. Well, okay, so far about the anatomy of insects. When we here on SEBA, we got this list of orders. It's actually quite, it fits one screen. It's quite comprehensible actually, it's not really a problem. Bad news is last week we encountered this thing, which means that now you have a new order here. So we shuffled that in this week. But, well, Nice list, right?
Yeah, easy, right? Just, yeah, learn this list and you become an entomologist. Come on. Now we're going to make some order into this and yeah, divide it into groups, and then suddenly it will make sense somehow. And we're going to try to start with the wingless insects, because yeah, back in the day when insects first developed, they didn't have wings yet, and so they were really really early. They walked around, couldn't fly, of course, way before the dinosaurs came. Kids never understand that. They thought dinosaurs came first. No. These guys jumping bristletails, but I'm now going to give an example of silverfish. You probably know them. They're in your homes, probably. But they're actually nice. Okay, they're called fish, not because they're in the sea. You like those fish, and people mostly don't like these. But they're actually quite, yeah, they're so old and so special. And I think they're called fish because they're scaly and because they sometimes move a little like a fish. You can recognize them by their three cerci, so these three appendages at the end of their body. And as I said, they don't have wings. Silverfish eat starch usually. That's what they do in your home. Um, but yeah, well, there's another species that's known worldwide, and it's called a paperfish. Well, that does not eat paper. There's another species that's actually called silverfish, so the whole order is called silverfish, but species as well. But that one, of course, does not eat silver. It also eats starch. This group is so old, it's ametabolous, as we call it. So it doesn't have any metamorphosis. The young silverfish, the nymphs, as we call them, yeah, they look just like tiny little silverfish, and they molt and grow older and grow larger. But even after maturation, sexually maturation, they can keep molding, and that's very, yeah, special for insects. Usually, well, when they are sexually mature, they stop molting. They don't need, yeah, to grow anymore. They only have to find a mate and, well, die actually. But not these guys. They keep growing, and that's, yeah, something special, I think. Okay, and then there was this great invention, wings, and Jan is going to tell you a bit about that.
Yes. Then at some point, um, something looking like a silverfish developed wings. And that was a great invention because the winged insects are the vast majority of insects. So this group is far more successful than the non-flying insects. Even this is still the vast majority of animals on Earth, as far as we know. Um, and we're going to look at one of those groups, which is in this case the dragonflies and damselflies. Dragonflies and damselflies are not very common here on Seba. Especially, there are only 3 species, I think, known. And the reason for that is that they're nymphs, so they're young. They live in water. They live in stagnant water, and there hardly is any stagnant water here on the island. Only artificially now there is, but from natural sources there's hardly anything. Still, there are some here. They have 4 wings, like most insects, and they spread them out, like in dragonflies, or they can hold them upright over their body, like in damselflies. So they can just flap them. That's what they can do. The whole order of Odonata, so damselflies and dragonflies, are hunters. And they're specially known. A really cool thing of this order is when they start mating. They form, the couple forms this shape which looks like a heart and which looks so romantic. Oh, sorry. Oh, where can't I go back? Back to Mar. But why do they do that? Well, the reason is that if a male finds a female, the first thing he does is grab her in the neck. But he does that with the very end of his abdomen, where his cerci are located. But bad for him, also his genitalia are located there. So he can ejaculate into her neck but she doesn't become pregnant, of course, by being ejaculated in the neck. So to actually transfer sperm, he has to do something else. And for that, this order has a secondary sexual organ. He has secondary genitalia. Males have 2 penises. And that second organ is located here, so at the very start of its abdomen. So before he grabs a female, if he's smart, he first transfers the sperm to his secondary organ, and then if he got the male by the neck, the female can put her genitalia, which are also at the end of her abdomen, towards his genitalia, and then sometimes he has some organs there to first scrape out the sperm of the previous mate. But when that's done, he can ejaculate with his secondary organ again, his sperm, but now into the female. So that's what the heart means. Okay. The next invention, and that's a really great invention, was to flex your wings. Because, you? Okay. Oh, I did that. Okay. So we have first the wings, but those wings are vulnerable. If you stick them out as a damselfly, they might get hurt. So if you put them over your body, your wings are protected. But then on the other hand, if you make your wings a bit more leathery or even really hard, they can protect your body. And that was the next evolutionary step, really important, because again, most of the winged insects can flex their wings over their body, so they can't only put them on their body, but they can also turn them, flip them. And that's what we see in all these animals.
Wait a sec. We're talking about winged insects now all the time. But what about these guys? Headlice and fleas and bedbugs? They don't have wings. No, they don't, but their ancestors did, actually. We call them secondarily wingless. So their ancestors did have wings, and then they found out, well, they could live on a host and actually live on their food and their mating site. So why have wings? It costs energy to develop wings, and they can only be damaged by scratching dogs or scratching humans. So they just, forgot about their wings and this. And then we have ants and aphids, of course, mostly wingless. Everybody, of course, sees directly that this is the aphid in this picture. Aphids are really cool, gonna tell you more about that, but usually they are wingless. And unless, it gets too crowded on a plant, or just if it's the season and it feels like it, some individuals suddenly do develop wings, and then they also develop larger eyes and larger antennae, and that way they can easily find a new host plant. And then there's an ant, here's an ant. You can see this is a pear-shaped thing, and this is a thing with a beautiful waist. So that's the difference. Easy. Ants are usually wingless, of course, unless they are males. There are males that have wings, and the queens that have wings. They use the wings to mate in the air, and then the males die, and the queens just lose their wings and start a new nest. But the workers wingless. And then there are crazy animals like some moths, for instance, where the females don't have wings, so they just crawl up a tree and are mated with, or sometimes taken along by a male and brought to another tree, but no wings. And then there are these guys, and these are larvae and nymphs, so juvenile insects, and they never have wings. But we still think of we still count them to the winged insects. Oh yeah, okay, and those winged insects, still a long list. We can divide it into 2 groups. See, easy entomology. First, there's the hemimetabolous insects, those with an incomplete metamorphosis. I'm going to explain what it is. And then there's the holometabolous insects, the ones with a complete metamorphosis. And I think Jan is going to tell you a little bit about hemimetabolous insects.
Yes. Yeah, there, as you can see, there's quite, well, it's about half of the list of orders that we have here, so that's a nice split. And we're going to talk about some of them. And the first one is the locusts and crickets, one of my favorites. Locusts and crickets, in a general, can be recognized by their thick thighs here, of their hind legs. And with that they can jump. Another thing which is often called as a kind of, as a characteristic of the group, is that they make sound. But that's not a real characteristic of this group, because it developed twice. I'll tell about that later. But many of the species occurring here do make noise. We're hearing some of them now, next to some stupid frog. When they make sound, the ones that do, it has to do something with a hardened wing in the forewing, at least. And we divide this group of crickets and locusts into two suborders. And the first suborder is that of the locusts and grasshoppers, and you can recognize them by their short antennae. Short means shorter than their body, less than 30 segments. And if they can sing, they sing by rubbing their hind leg, their hind femur, over a hardened vein in their forewings. And that femur has on the inside a whole series of pegs, and those pegs get pushed by this hardened vein, and that produces a bit of a scraping sound. But yeah, it can be heard. It's completely senseless for a male to start singing and hoping that a female will hear you if they don't have ears. So they need ears, and they have it there. Thank you, Aglaia. Ah, great. Yeah. On the other hand, that's where the ears. And grasshoppers and locusts are vegetarians. They're eating grasses, maybe some other plants, but usually mostly grasses. The other suborder is that of the crickets and bush crickets. Some are vegetarians, others are carnivores, omnivores. Some of them are eating really anything they can lay their jaws on. But in general, they have long antennae, more than 30 parts, more than 30 segments. The subgroups of crickets that can sing by lifting their wings, their forewings, and rubbing those two over each other, where the wing which lays on top has a vein like this, and the other one has a vein like that, and this one goes over the other one, and that's more like playing a violin. Sounds of crickets are far more harmonious than those of bush crickets, than those of grasshoppers, and also their wings have this completely special pattern. The males have an enlarged basal area, which can make the sound carry further than would normally be the case. So that's a really special organ. But like I said, only the males have it. In the grasshoppers, females can make sound, and in some species, even females do reply to males. But in crickets and bush crickets, or katydids, like Americans call them, only the males have this organ, only males can make sound. And again, if you want to be heard, you need an ear. But crickets have their ear in their forelegs, and they got it just under their knee, in their chin. This is where I can just see it, that's where the ear is. Well, hearing that they're making sound in completely different ways, but also the ears have developed in a completely different place, makes clear that development of sound isn't an original character of this order. It developed twice in groups within those two suborders, so it's a kind of happy occasion that now most of the order is making sound, but it's evolutionary, it's two completely different developments. The next group. Well, yeah, when we found it last week, we thought, yeah, we had deleted this order from this presentation because it wasn't here. Now it had to come back, and now we made a special thing about it because it's really a cool order. I've seen it a few times in my life before, but not often. For you, it's the first, right? Web spinners, Ambioptera. You can recognize web spinners by their swollen forelegs. It's their foot actually. So their 4 feet are swollen, and they're swollen because they're able to spin silk with it. And with this silk, they can form galleries. They make a kind of tunnels, a whole gallery system of tunnels, and they live in those tunnels. So they shape their own house. And this house protects them from predators, but it also keeps their family together. And you can find those galleries on or under stones, bark, and litter. And that's what they eat, organic waste like litter, leaf litter. The other cool thing is that it keeps their family together. Yes. A question. Do you know Anna Keen? Where we're looking at in this neglected swimming pool pond of hers, and suddenly a male landed on the bank of it while we were looking for damselflies, and I thought, I think I just caught an Ambioptera. Yeah, and at home, yes, I did. Now you know exactly where we found it, but it would be quite interesting to find their nests actually, because yeah, that we only have one male now, and it came flying there, so I have no clue. Yeah, well, I don't know, but
We're going to look for them tomorrow.
they live socially. So such a gallery system has one or a group of females with all their offspring. And the females have parental care, which is also something which is rare in insects. Most insects just drop their eggs and the youngs can look after themselves. But here, the female first takes care of the eggs, and later on she starts feeding her youngs, at least in some species. As soon as a male matures, he leaves the nest, starts looking for a mate. If he does, he mates, and then he dies. That's the life of the males. The males, to look for mates, in quite some cases have wings, just like the one we found last week. But so in some species, even the males don't have wings. But the females are always flightless. So if you see an Ambioptera with wings, you're immediately sure it's a male. And then I'm going to give this to you again.
Yes, I get to talk about bugs. Bugs is a confusing word, of course, because a lot of people call all insects bugs.
Yeah, like
His
t-shirt
shirt
guy.
is totally wrong in that aspect. But the insects that we call bugs, the Hemiptera, they can be recognized by having this rostrum, as we call it. It's so that they have this piercing, sucking mouth parts. You can imagine them like some built-in straw, actually, so they can only drink. And it's quite a large order, so it can be divided into 3 suborders. That makes it easier again. First, there are the aphids. Now I get to talk about how great aphids are, because most people don't like them, and that's not really correct. Aphids are important. Aphids are a tremendously important food source for a lot of other insects and other animals, even birds. And also they drink saps from your plants. That's why you don't like them. But they get way too much sugar inside them, and they have to release it. They have to excrete the sugar, and we call that honeydew, but it's actually just aphid poop. And lots of insects love honeydew. Bumblebees do, and butterflies do, and of course ants do, as you saw in the picture earlier. Ants actually herd aphids. They keep them as cattle. So how cool is that? So aphids are amazing. Another group within the Hemiptera are the Wieringa, the plant hoppers, and Americans will know the cicadas, of course. Beautiful little animals. and there are what they call the true bugs, as if aphids and plant hoppers aren't true bugs, but okay, whatever. The Heteroptera, yeah, you have quite a lot of species of those here on Seba. I found quite a lot already, but still, oh, I'm going too fast. I think, no, I'm not. Okay, you.
No.
Oh, me, sorry. I'm going to give this example. Yeah, this is an example of green shield bug because that's why I could get a lot of pictures of its development. I don't have a lot of pictures yet of those on Seba, but it's the same idea all over. These are, nymphs that just hatched from their eggs. They're tiny and small and red. But after their first molt, they lose all the red and they're green and black. And after the next molt, a lot more green, and then only green. Now you see the wings starting to develop, and then it turns into this beautiful animal. And in the eyes of a lot of people, these look like a beetle, but there are clear differences. At first, they have this rostrum, right? I showed you, it isn't visible in this picture because it holds its rostrum, below its body. But beetles have jaws, they have chewing mouth parts, they move like this, not like this as ours. So that's a very clear feature. They've got this large shield that's here on the green, and their wings are very different from beetles. Beetles have parallel forewings that are hardened, and with these only the basal parts is hardened, and usually a bit leathery and quite brightly colored. And the hind part, here's the front part, the basal part, and then the apical part, so the hind part, that's membranous and colorless usually. And these forewings, they lay over each other. You sometimes see some kind of a drop form at the end.
Like that.
Yeah. True bugs have only a few antennal segments, where beetles have more, like up to 11. Those are the antennae. And of course they have incomplete metamorphosis, where beetles have complete metamorphosis. You see that immediately, all of you, right? So easy. Yeah. Okay, so this brings us to the next group.
Yeah, so the group with complete metamorphosis. And this group, the holometabolous insects, have larvae that don't look a bit like their parents, which actually also gives us an opportunity. Because if you look completely different, you can live in a completely different habitat. Because you have to know, youngsters need different food than adult insects. Youngsters need proteins. They need to grow. They need to build this mature body. While a mature insect, when it's a female, might need some protein to be able to produce eggs, but they also need energy. So they need sugars to fly around and look for mates and go somewhere to find a new place to deposit eggs. So they need different food, and you can do that when you're completely different. So again, we have a nice list of orders that belong to this that belong to the holometabola, and let's look at some of those differences. Here we see this beautiful lacewing, a very elegant insect, but its larva is quite an ugly monster with two hollow jaws. So as soon as it grabs its prey in its jaws, it can immediately start sucking all the life out of it. Another one that you all know well. Here we have a caterpillar, which is feeding on plants. It's eating leaves. But then once it is a butterfly, it starts visiting flowers and is looking for nectar, so for sugars. Or another group. Here we have a maggot, and in this case, this is a maggot that is hunting for aphids. It's running over leaves. Well, hobbling over leaves. It hardly has legs, but it's hunting for aphids. While the fly is visiting flowers again. This hoverfly is visiting flowers and is drinking nectar. And last example, we have a ladybug, which is actually a beetle. Again, this bug thing, where the larva is quite ugly and again hunting for aphids. You can see how important aphids are. Yeah, and I think now Aglaia is going to show one of her favorite beetles.
Oh, yes. This beetle I bred when I started first studying entomology. And so I know it very well, and I've got tons and tons of pictures of it. And this is, oh, such a cutie, just born, just hatched out of its egg. It's about a millimeter, really, really tiny. Okay, millimeter and a half, perhaps. Okay, then it eats rosemary, but actually it likes lavender better. So I think it should be called the lavender beetle, but okay, it's called the rosemary beetle. And it eats and it eats and it molts. And it gets larger and larger till it's about this big. Well, quite big for an insect in our view. And in the end, it becomes this beautiful little gem. But how does it go from that, well, okay, perhaps in the eyes of some people not so cute little larva into this beautiful beetle? Well, that's through the pupal stage. When the larva is fully grown, it molts again, but below the old larval skin isn't a new larval skin, but there's a pupal skin. Sorry. And within that pupal skin, that hardens, and the larva actually dissolves in it. It just becomes a protein-rich soup. And nothing stays where it is, only the very important parts, like parts of the neural system, will stay floating around. And there are imaginal discs, and they grow out to become the larger eyes to find a mate with, the larger antennae to smell the mate with, or the lavender or the rosemary, and of course the sexual organs and the wings. So holometabolous insects always have a pupal stage, and that's actually the difference with the hemimetabolous insects. So we've got this huge diversity, and we hope to have given you a little bit of a filing system, as it were, so you can place them in some kind of group, and at least give you some insight in groups. And we've got a little bit of, what's he doing? A little bit of a quiz. So I'm going to ask you, where does this one belong? It has wings, right? It's a damselfly, exactly. So can it flex the wings over its abdomen? No, right. Easy, right? Entomology is so easy. Okay, now this one then. What is it? Okay. Oh, that's for later. Okay, that's for later. Okay, anybody any idea what this is? It's a robber fly, so it's a fly. And what does a fly larva look like? It has wings.
Yeah, flexi wings.
Yeah. And do they have a pupal stage? Does the no?
Yeah.
No. Yes, it does, because the larva is a maggot, and it doesn't look like a fly at all. Yeah. We'll do a couple of more, and then you get the hang of it. It's really easy. Okay. Jan doesn't have any sound anymore, so I'll just go on. I can do this.
Yeah. What do we have here? Yeah, a bushkriget. And they can fly, right? Only here the wings nearly seem integrated with the rest of the body, but we all know that they can fly. And clearly, because it's kind of integrated, it's clearly flexed over it. How does a young cricket look like? Is that like a maggot or a caterpillar, or does it look like a mature cricket, more or less? Yeah, more or less. So indeed, we're dealing with a can flex, but still hemimetabolous insect.
Now this one then, does it have wings? Yeah, it's so easy. Yeah. Okay. Okay, and you know this one. There's actually a different kind living here. It looks like Sedeka. It's the same genus exactly. So Hollow, I think, because
Do you ever see young jackies crawling through your house?
no. So
Yeah, no.
their larvae are actually just intestines with mouth parts, and that's it. They only have to eat.
They look
Yeah.
like a maggot.
Yeah. So they are holometabolists. Yeah. It's easy. Holo. It's complete. Holo means complete. Yeah. 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 Okay. Then this one.
Yeah. Yeah, we're really sorry, but we're in the wrong time of year, apparently. They occur here in April. This, if you don't recognize it, is an antlion. Quite large insects. They look a bit like damselflies, but they have longer antennae. And they can flex their wings. Haha. Do you know how the larva of a antlion looks like? They kind of dig in the sand, and then they throw away the sand until there's a kind of funnel, and they're sitting at the bottom waiting until some poor ant runs into this funnel and then tries to escape, and it throws more sand over it until the ant ends up in his jaws.
In any case, it doesn't look at all like this
No.
one. So then it is a.
It's actually related to the lace wing,
Yeah.
but then it's even more ugly.
Holometabolists. Okay. Last one in this session. What's this? It's one of my favorites, actually. Do you know most cockroaches are actually social insects? And the young ones cannot develop well without parents running around. And they don't even know how to act as when trying to find a mate. Okay, so cockroaches are nice. And most actually do not like to live in our houses. They live outside, they never come inside. Only by accident. Okay. So where does it? Yeah, sometimes by accident, and some really only can live with us. Yeah, that's true. Okay, so where does it belong? Yeah, baby cockroaches, exactly.
Yeah.
So, hemimetabolists, yeah, it's easy. Yeah, cuties, yeah. Okay,
Okay, and now
this part is over. We've got some
we
more.
brought some of the insects that we already found here. Let's see if we can make some visible with the camera. Yeah, this one. We'll start with this one.
Sorry.
No.
Yeah.
What's that?
Ah, yes, yes. Or at least a couple of days ago, yeah.
Yeah,
it
you
is
can
a
recognize
fly.
a fly because it only has 2 wings instead
Yeah.
of 4.
Yeah, so a young fly is a.
But
Mega-
this fly tries to look like a wasp. So for some of you, it succeeded actually, because of course wasps look dangerous and can sting, and flies are completely innocent. So they try to look like them.
What else?
What's
Try
next?
this one.
That one. Yeah. Well done. That's not a baby. It's a little. Yeah. This is a wild fur species. Yeah,
Yeah,
the
there's
male
some-
ants here.
Yeah, there's some running around here.
So
I'll
let's
collect them
try
by closing
this
the
one.
suitcase.
Yes, exactly.
Yes. The new one. I can tell you, they handle the freezer very well. They just keep on living. It's scary because it's.
But what is it?
The male of.
Sorry.
Oh, I don't know.
Yeah, yeah. Keep.
Don't know. I think we've got males and no, that's not a web spinner. No, no. This is a beetle, actually. Yeah.
The 4 wings are hardened. It's a weevil. Yeah. Yeah, it's within the superorder of beetles.
So, okay, tell me, beetles, are they holometabulous
Let me do
or
this one.
hemimetabulous? Okay,
Oh, sorry.
okay,
Yeah.
yeah. Mm.
What about this one? That one? Yeah.
That's difficult. Yeah, correct.
Yeah, you're correct.
Yes,
But it's a green one.
it's a beautiful green rose. Oh, so pretty.
Yeah.
The milk running off. Yeah, male ants.
This one, I think.
Okay, yeah, last but not least, because this
This is a
one
really
is
nasty one.
difficult. No,
Well,
it's correct, yeah.
Yeah, Schildbad is nearly correct, but it's a family next to it. But yeah.
Yeah. But now the word bug is correct, come on.
Yeah, sure.
Bec-
Those are two nymphs.
yes, yes. We just picked them, yes, we just picked them from the branches and these nymphs were there, so
Killed the whole family.
Yeah.
Yeah.
Likely the nymphs were protected by
by
the
the mother,
females
yeah.
sitting
So
over them.
she probably sat over them, so we didn't see it. Sorry? The dots? What do you mean? Oh, how large? Oh, only two. We only found two, but usually.
No. Here, this one.
Oh, the dots on the bug itself. I think four. Yeah.
Well, 4 big ones and tiny ones. Yeah. Right, it's difficult to. If you turn it a bit, you might see that as below there's also some tiny. Yeah, no, you can see it. Yeah. I'm going to close this box because it's getting completely swarmed by by ants.
It's a way of conserving them. Yeah. Okay. So, any questions left? Any questions left? Have we seen a beautiful flying bug, which is with a red body? Could be. Do you mean a bug or do you mean an insect? Okay, an insect with. Oh, we've seen quite a few red insects, more than in Europe actually. So I.
This dragonet wasp.
Yes, this great wasp. Yeah, yeah. Yes, but we also found a true bug, which is red. It's assassin bug. Yeah. No, but an assassin bug also red. Was it near what do you call it? That. Okay, near some flowers. Hmm. Okay. Okay. Possibly. Yeah. It's difficult. You should take a picture and just.
There was this of the bear families of moths. There,
Could
it
be,
has a
yeah.
orange-red body and
Yeah.
kind of whitish dotted
Yeah,
with black
could be
dotted
that
wings.
one. Yeah.
Maybe that one.
Haven't collected it yet, so if you can. Yeah. Okay, that could be. Yeah. Oh, then they mean a hummingbird moth.
Oh yeah, but
Yes.
you don't even see its wings. It's flapping that fast.
It's really fast, yeah. But the body is red often. So yes, I can imagine that's what they saw. Okay, yeah, just catch it.
But that's pretty big. That's
Yeah,
this size.
yeah, it's big. Yeah.
That's actually a hawk moth. But it's a hawk moth that can flap its wings really fast. Just. Well, actually, in
There
Europe
are many, yeah.
we also have a species that does this, but it's strange because all hawk moths are nocturnal, but this species is diurnal, so you see it during the day, and yeah, just like a hummingbird, it's visiting flowers. It isn't resting. It's just with its long tongue going into flowers and then to the next one, and it's the wings are so fast that you can't see them. But it is a hawk moth.
just catch it and collect it, and yeah, we'll bring it.
And it's,
see.
it's called hummingbird hawk moth, which is completely stupid, of course, because those hawk moths were there long before the hummingbirds.
Question there.
Is there typically less diversity of the non-flying insects on islands, just based on difficulty of getting there?
Yeah, I
Um,
think that is the case. I don't have hard data for it, but yeah,
Yeah,
I
but
would say so.
no, Oscar had this paper. He at least he told me about that there are actually more species of non-flying insects because the flying insects just get blown out into sea and have more difficulty staying here. So that that diversity is actually larger. But of course, getting here is a problem. So that's. But if you're here, yeah, you're okay.
It
Right.
depends on the size of your island, and
Of
yeah,
course,
then it
it's-
gets
yeah,
complicated.
It's insects. It's easy. I told them it's easy. Come on.
No, but we have had trouble finding springtails. There were some, but we didn't see many of them.
True. They're not
Um,
insects.
Yeah. And also for Orthoptera, for instance, we've only found winged Orthoptera, more or less. Although some of those crickets can't fly, but they're endemics then. Yes.
Well, yes. Are we setting up night traps? Well, actually, we've got a light trap. That's actually a bucket with UV light that turns on automatically when it's dark. So it's on now. And tomorrow morning we can just go and look. Yeah, see what we got.
See
and
what
that's
landed in the bucket.
usually moths, but there are also sometimes very interesting wasps in there. Usually only one, but okay. and some beetles, and yeah, it's quite interesting.
And some
to see.
bugs. We found some bugs
Yeah.
too. Yeah.
True, yeah.
But
True.
sometimes we're too late, and then the ants got up to our
Yeah.
mouth. Yeah.
Yeah. One last question. Okay, do locusts and grasshoppers and bush crickets only sing to mate, or do they find for fun? Well, insects don't know fun.
No, in principle they only do it for mating. However, I do know of one genus of European bush crickets where the males kind of rape women, so they just jump at them and start mating, and only then they start singing. So that's weird. And we don't know whether that still is to get the female into a mood or something, or it's not clear. So that's a question mark. But yeah, normally they do it for finding mates, but also for it's also a competition between males. So in the Netherlands we have one species that only does and then really waits a long time, then. But when a second male is close, then one says the other says so then even if you only listen to one, you can hear that the other one that there is another one clear nearby, because the frequency of its chirps is getting shorter. Yeah, they don't really have a territorium, but it is a kind of competition. Yes.
But in Grillis, you do have this territorial song.
Well,
Yes,
they have their own burrow. Yeah.
Exactly. So territorial.
Yeah, so that's
Okay.
their burrow. But the next burrow could be quite close.
Lynn is done with it. You can see it. Yeah. Okay.